Hello there, Mr. Sutton here, bringing you the IM 3 Honors 1-6 Extra Practice Number 2 solutions on transformations. To graph this square root function, I'll start with the parent table for square roots using the points 0, 0, 1, 1, and 4, 2. And let me keep track of the transformations going on. So there's a few of them. This negative 2 outside is both reflecting and stretching the graph vertically. We're basically multiplying the y values by negative 2. The minus 2 inside is shifting us to the right 2. It's the opposite of what you would expect because it's inside the function. And then the plus 5 outside is shifting us up by 5. So stretch and reflect vertically, shift right 2, up 5. Let's put all that in a new table so I can change these original points around a little bit. The only thing happening to the x values is this right shift of 2. That's just going to add 2 to every x value. For the y values, we said we're multiplying those by negative 2 and going up 5, so I have to do negative 2y plus 5 if I'm doing this algebraically. Let me go ahead and add 2 to all the x values now. So that 0 plus 2 is 2, 1 plus 2 is 3, and 4 plus 2 is going to be 6. Now for the y values, again, we have to multiply by negative 2 and add 5. Negative 2 times 0 is 0, plus 5 is 5. Negative 2 times 1 is negative 2, plus 5 is 3. Negative 2 times 2 is negative 4, plus 5 is going to give us 1. Let's put these points on our graph now. So we've got 2, 5, that's right here. 3, 3 is right here. And 6, 1 right there. Now, which one of these is our starting point? Well, 0, 0 became 2, 5 when you transformed it. So this 2, 5 right here is the endpoint of the square root, and we're going to go in just one direction the other way through the other points to get the rest of the graph. To transform this square root function, let me start with the original parent function table with 0, 0, 1, 1, and 4, 2 that I know are on the original graph. Now for transformations, the 5 outside here is a vertical stretch. We're multiplying y values by 5. The minus 8 out here is a y value shift. We're shifting down by 8. So making a table to reflect all that. The x values are not being changed at all, so I'll just rewrite those in a minute. For the y values, we're doing 5 times y, and then shifting down 8 means we have to do minus 8. So again, x values not changed, 0, 1, and 4, still the x values. For the y values, though, 5 times the y and then subtract 8. We've got 5 times 0 minus 8 is negative 8. 5 times 1 is 5, minus 8 is negative 3. 5 times 2 is 10, minus 8 is 2. Putting these on a graph, we have 0, negative 8 for our starting point. That's right about there. 1, comma, negative 3 is right there. And 4, comma, 2 is all the way up here. The 0, comma, negative 8 point, that is actually our starting point for the square root because that used to be 0, 0. So we'll start all the way down here and then go one direction through the other points like so. We're trying to graph this square root function now. So to do that, I'm going to start with my table of values with my 3 points I always use, 0, 0, 1, 1, and 4, 2. And I need to transform these now according to what's going on with this function here. This negative outside the function, because it's outside, it's vertical. It's going to be a vertical flip, basically multiplying the y values by negative 1. The plus 3 inside the function is actually the opposite of what you expect. This is shifting the graph left 3. So incorporating that, a vertical flip and a left 3 shift into my table. For my x values, I'm going to actually have to do x minus 3 to go left 3 for all those x values. And for the y values, again, we're just multiplying those by negative 1. So for my x values, going down with the original x values here, we've got 0 minus 3, that's now negative 3. 1 minus 3 is negative 2. And 4 minus 3 is 1. For the y values, we're just negating all those. 0 is still 0, but now we have negative 1 and negative 2. Putting those on a graph, we've got negative 3 zeros right here, negative 2, negative 1 down here, and 1, negative 2 is right there. Okay, now because the graph started at 0, 0 initially, and that point has now transformed into negative 3, 0, this negative 3, 0 is our new square root starting point. So we're starting there and going through the other points in that direction forever. To graph this square root function, let me start with my table of my 3 points, 0, 0, 1, 1, and 4, 2. And now for the transformations going on here, the 3/4 outside means that we are, this is actually going to be a vertical shrink because it's less than 1. We're basically multiplying the y values by 3/4. The +1 inside means we're shifting left 1, opposite of what you expect. And then the +1 outside means we're shifting up 1. So we have multiply y values by 3/4, and then we're going left 1 and up 1. Okay, so let's do a table with some new values now based off of all that. For the x values, because we're going left 1, that means we have to subtract 1 from the x values. And then for the y values, we're multiplying by 3/4 and shifting up 1, so we have to add 1 there. So I'll write 3/4 y plus 1. Now let's calculate what that's going to mean in terms of new values for x's and y's. For the x's, subtracting 1, we've got 0 minus 1, so negative 1. 1 minus 1 is 0, and 4 minus 1 is 3. Next, for the y values, 3/4 times 0 is still 0, plus 1 is 1. 3/4 of 1 is still 3/4. Plus 1 is going to be 1 3/4, or 1.75. And then 3/4 of 2, that's actually 1.5. Adding 1 to that gives me 2.5. Graphing all that out as best I can, because we've got some decimals here. We have negative 1, 1 is right there. 0, 1.75 is roughly here. It's pretty close to 2. And then 3, 2.5 is about there. And we're starting at negative 1, 1 because that was originally our starting point of 0, 0. So starting there, we just draw one direction through all those, and there we go. To graph this square root function, let's start with a table with my 3 points, 0, 0, 1, 1, and 4, 2, that I always use for the parent function for square roots. And now to transform these, this 4 outside here means we are stretching vertically, multiplying the y values by 4. The minus 3 inside means we're shifting to the right 3, opposite from what you expect. So making a table to incorporate this, the x values, since we're going right 3, we're going to have to do x plus 3 for all the original x values. For the y values, we're just multiplying by 4, so 4y. Let's transform the x's now. So we got 0 plus 3 is 3, 1 plus 3 is 4, and 4 plus 3 is 7. Now we're going to multiply all the y values by 4. 4 times 0 is 0, 4 times 1 is 4, and 4 times 2 gives us 8. Putting those on a graph, 3, 0, that's right about here. And then 4, 4, right up there. And our last point, 7, 8, that's going to be right here, I believe. Yep. Now, since we started with 0, 0 for the original square root function, that's the endpoint. 3, 0 that came out of that is the new endpoint. So we're starting at 3, 0 and going through the other points in one direction. To graph this square root function, I'm going to start with the parent table with 0, 0, 1, 1, and 4, 2, the same points I use every time I do one of these problems. And then let me transform that using what I've got in this function here. The 7/4 outside means that we are stretching vertically, multiplying y values by 7 over 4. For the x's, this x plus 4 in here means we're actually shifting left 4, so we'll deal with that in a minute. And the plus 3 outside means we're shifting up 3. So making a table to change my x and y values, since we're going left 4, that means we have x minus 4 in there. And for the y's, we said we were multiplying by 7/4, so I have 7/4 y, and then up 3 means plus 3 for the y values. So let's change the x's first. 0 minus 4 gives us negative 4. 1 minus 4 is negative 3. 4 minus 4 gives us 0. A little bit more work on the next one now. We have 7/4 times the y plus 3. 7/4 times 0 is easy. That's still 0. Plus 3 gives us 3. 7/4 of 1 is 7/4, or I guess you could say 1.75. Adding 3 gives us 4.75. And then 7/4 of 2, that's a little bit trickier. So that would be, let me think here, that would be 14 over 4, and that would be like 3.5, but now we have to add 3 to 3.5, so that'd be 6.5. All right, feel free to use a calculator if you need to for some of these. Moving forward, now we're going to graph these 3 points on the axes over here. So we have -4, 3, -3, 4.75. So here's 4. This will be about 4.75 right there. And then we have 0, 6.5. So there's 3, 4, 5, 6, and a half puts us right there. The starting point for this square root is going to be -4, 3, because that was transformed from the old starting point of 0, 0. So we're starting right here and going one way through the other 3 points. To graph this square root function, let me start with my table with my 3 points, 0, 0, 1, 1, and 4, 2, that I always use for square roots. And for transformations, this -5 outside means we're multiplying the y values by -5, so that's a vertical reflection and stretch. The -1 inside means we're actually shifting to the right 1, opposite of what we expect. And +4 outside means we're shifting up 4. So to review, reflecting and stretching vertically, multiply y by 5, and then growing right 1, up 4. So for x and y values, for the x values, a right shift of 1 means we're doing x plus 1 to all of the originals. And for the y values, we're multiplying by -5 and going up 4, so adding 4. So -5y plus 4 is how we represent that. Applying those changes to my original values, adding 1 to the x's, we've got now, instead of 0, we have 1. 1 plus 1 is 2, and 4 plus 1 is 5. For the y values, we're doing multiplying by -5 and adding 4. So -5 times 0 is still 0, but we're adding 4 to that to get 4. -5 times 1 is -5, plus 4 is -1, and then -5 times 2 is -10, plus 4 is -6. Putting those on a graph, we have 1, 4, which is right here. 2, 1, -1 rather, is down here. And 5, -6 is going to be right here. We're starting at 1, 4 because that was originally the start point of 0, 0. So starting right here, drawing in one direction through those points, gives us our transformed function. To graph this square root, I'm going to make a table with the 3 points I use the most from the original graph and then transform those. So I've got 0, 0, 1, 1, and 4, 2 are my go-to points for square roots. And now for the transformations, the negative outside is a vertical reflection, so multiplying the y's by -1. The -2 inside means we're shifting right 2. The -3 outside means we're shifting down 3. So reflect vertically, shift right 2, shift down 3. Changing my x and y values accordingly, the x values, it looks like, since I'm going right 2, those are going to be added with 2, x plus 2 there. For the y values, we're negating the y value and then adding, or actually subtracting 3 since we're going down 3. So -y minus 3 captures all that. So for the x's, let me add 2 to all those. 0 plus 2 is 2, 1 plus 2 is 3, 4 plus 2 is 6. And then for the y values, I have to negate and then subtract 3. -0 is still 0, minus 3 is -3. 1 becomes -1, minus 3 becomes -4. And then we've got -2 minus 3 giving us -5. Putting these on a graph, we've got 2, -3 to start. So that's right down there. 3, -4. And let's see here, we're going over 6 and down 5. Now, since 0, 0 got transformed into 2, -3, that means 2, -3 is the new endpoint for my square root. So I'll start here and go one direction through the other points, like so.